Hey guys, I really miss seeing you guys. I was hoping by now we would be able to get together and do some lecture. I'm not quite sure what the remainder of the year is going to look like. So I'm going to do the lecture videos for this module for you guys to be able to watch. I'm not going to lecture on every little thing in this module, so make sure you read. We are scheduled for lecture on Tuesday and Thursday of this week. Then instead of being off next Tuesday for Performance Day, we will just go ahead and have lecture that Tuesday, Thursday, and be done next week. So you'll take your test at home next week, whatever works for you for Thursday or Friday. And then we'll try to make a decision about if we can get together and do our pig dissection after we've been let off of some of these orders. So we'll just kind of play that by ear and see what goes along with it. So you can you can take your test, your final test Thursday, April 30th, or Friday, May 1st, like whatever the end of next week, whenever you're ready for that. I still have only gotten sorry, my kids are in there eating lunch. And somebody's plate just hit the floor. I still have only gotten a few tests from you guys, so get those sent to me if possible, please. Or have your parents communicate with me like what the plan is for you guys. Okay, so let's get started on Module 16, the reproductive system. So we'll be on page 516 where it starts. Humans reproduce sexually, which allows for the mixing of genetic material from two organisms that produce offspring that are similar to but not identical to their parents. You have four main functions of the reproductive system. You have the production of gametes, the sperm in males and ova or eggs in females. This happens by meiosis, and we will actually talk about that later. Fertilization, that's the joining of the egg and the sperm, then the development of the new individual inside the female, and then the production of reproductive or sex hormones, which of course are gender specific as well. So the anatomy of the male reproductive system is what we'll go through first. Figure 16.1 will be on your test, so make sure you know the figure. Also, the vas deferens is, a little bit further down. They have that pointing in a different arrow point on the test. So make sure you look at the study guide and also figure 16.1 for that one. Okay, so the testes secrete sperm and they produce and secrete your sex hormones. They're the functional center of the male reproductive system. Testosterone is the main sex hormone there, and it's housed in the scrotum, which is a sac outside of the abdomen. The scrotum is necessary because of spermatogenesis. That's a definition you need to know for your test. So spermatogenesis is the process by which sperm forms in the testes. So again, the scrotum is necessary because of being able to develop sperm. So spermatogenesis cannot occur at normal body temperature. So normal body temperature is 98.7 degrees, but sperm are developed most actively at around 95 degrees. So it has, the scrotum also has lots of sweat glands around it to help keep the temperature down. So it's on the outside of the body, so that it's away from the body, right? So if it happens better at 95 degrees, if it's in the body, it's going to be 98.7 or 98.6, somewhere around there is normal body temperature. Well, that would be too warm, so you would not be making sperm. So the scrotum being on the outside of the body allows the testes to be away from the body, to be cooler, and also it has lots of sweat glands to help keep it cool as well, to help you produce sperm. The scrotum can also regulate its own temperature. The cremaster muscle is it's an extension of an abdominal muscle that goes down into the scrotum that actually contracts and will pull the testes closer to the body when in cold temperature to help increase the temperature so that it's not too cold. if the scrotum gets too warm, that muscle will relax to move it away from the body to decrease the temperature. So all of that is there for the production of sperm. So all of that happens to make sure your scrotum stays at the right temperature so that the testes can make sperm. Figure 16.2 shows you a picture it gives you an internal view of what the testes look like. So sperm are formed in the testes, but they mature in the epididymis. That's the coiled tube, which you can see it's really long. It's about 20 feet long inside the testes. Once it's mature, which takes about 10 days, which sperm is mature, which takes about 10 days, they travel to the vas deferens, or the ductus deferens. These are about 18 inches long, and they move the sperm to the ejaculatory ducts and then out into the urethra and into a woman during sexual activity for possible fertilization. So that's how it moves to get out. Semen, that's another definition that you need to know, is a mixture of secretions from the testes and other male reproductive glands that is released during sexual intercourse. The seminal vesicles, they open into the ejaculatory ducts to secrete a fructose-rich, slightly basic fluid that makes up about 60% of the semen, and this is what provides the nutrients and the fuel for the sperm to actually swim to get to where it needs to go. The prostate gland here in your anatomy, you can see if you turn back to figure 16.1, it secretes a fluid that makes up about 30% of the semen, and it's slightly basic to help kind of neutralize the acidity from the vagina. You have two common problems with the prostate gland. Both involve tumors of the prostate. So one is benign prostate hypertrophy. It's not cancer, but it is a swelling of the prostate gland, which compresses the urethra, which is what you pee out of. We know that. And it slows the stream of urine. So, and it can compress the bladder as well, causing frequent urination. So once that enlarges, it puts pressure on the urethra, which causes slow urine. And if it gets large enough, it can put pressure on the bladder to also cause frequent urination. It pushes on it, makes it not be able to take up as much space, and makes you feel like you need to go more frequently. And then the second one is actually prostate cancer. It's the second largest cause of cancer in men. The prostate can be felt during, a rectal examination. And it should be yearly. You should get a yearly rectal exam after the age of 40 for increased risk, and at 50 for an average risk, because it can be so deadly. So if you have a history of that in your family, you would want to start getting checked around age 40. If you don't have a history of it, 50 is fine. So that's prostate cancer. It is the second largest cause of cancer in men. So you've got to pay attention to that. All right, we're going to skip over some of that stuff that's next and go on to page 521. So make sure you read the other stuff on there. We're going to skip to page 521. This is talking about meiosis. You guys had this in biology, so I'm not going to go over all of these little things. You get one copy of DNA from the mom and one from the dad. They're similar but not identical versions called alleles. So the summary of meiosis in 16.4, we're going to go over that. So how does meiosis 1 happen? First up, the chromosomes and the centrioles replicate. The second thing that happens is the spindles begin to form and homologous pairs are lined up. So XX and XX, all of them start lining up. Stages 3 and 4, the spindles will attach and start pulling apart the pairs. So the X's are being pulled apart. Telophase has each set. Stage number 5 has each set surrounded by nuclear material. So it comes in and encapsulates it. And they start pulling so far apart that they're going to end up pinching off and pulling away. So the result is in 2 haploid cells with identical chromosomes. So you have the XX and the XX. So 2 identical cells with the same exact chromosomes. So meiosis 2, what happens there is the chromosomes are going to replicate. And the second stage, it's going to line up on that equatorial plane. The microtubules are going to pull the replicates apart. The plasma membrane is going to constrict and the nuclei is going to form. And the result is that you're going to have 4 gametes with a single chromosome. So 23 on each. So it's either the haploid gametes, either going to be the sperm or an oocyte. And in that, 23 and 23. So meiosis is going to produce a different end product for males and females, right? It's going to have the sperm or the oocyte. Spermatogenesis, that is we've learned the development of sperm. So it goes into a little bit more detail here. So it takes place in the seminiferous tubes of the testes. That's, you can look back at figure 16.2 to get a better picture of that. But 16.5 gives you the process of how this happens. So the spermatogonia are diploid cells. You have 46 chromosomes that undergo mitosis, not meiosis, to form 2 separate cells. The spermatogonium, that's a definition that you need to know for your test. This is a singular of spermatogonia. Then you have the primary spermatocyte. This is a cell that actually undergoes meiosis 1 to make 2 secondary spermatocytes. Those go through meiosis 2 to separate the replicas, and they make a total of 4 spermatids, and you need to know what that is as well. So a spermatid, which is a cell in the testes that has 23 chromosomes, so it's already separated. The spermatids move to the epididymis to mature, right? They've got 23 chromosomes, they're going to move there, they're going to mature. The process of spermatogenesis takes about 7 days. So all of this developing of the sperm to be able to get the mature cells takes about 70 days. The sperm can live several weeks inside of the male, but it doesn't move on its own. So sperm can be divided into 3 sections. You have the head, you have the midpiece, and the flagellum or the tail. The tip of the head has a cap called an acrosome that has a digestive enzyme in it to digest the ovum. So once it gets to the ovum in the female, it has that on the tip of the head of the sperm. It has something in there to help dissolve the egg so that it can get in there. So the rest of the head has the nucleus with the 23 chromosomes in it. So it's got the part that will help dissolve the ovum for it to be able to get in, and the rest of the head has the chromosomes in it. The midpiece, which you can see in figure 16.6, the midpiece has many mitochondria. It has a lot of energy in it so that it can actually move the sperm. The tail of the flagellum, it just beats back and forth to swim to get to the ovum to fertilize it. So it's long, the tail is really long to make it very mobile, and that's its one and only job. It's just to get the sperm to the egg. Once it reaches the ovum, only the head will enter and contribute the chromosome, but not the mitochondria. So only the head of the sperm goes in, giving it the chromosome, the 23 chromosomes, but none of the mitochondria. So none of that mid piece that gives it the energy goes into the ovum, only the head portion. The sperm cells are the smallest of the human cells. You have about 60 to 90 million in 1 milliliter. That's a lot. If the number drops to less than 40 million, you're considered to have a low sperm count. And if it decreases to about 20 million, the man is usually infertile. It still seems like so much sperm, and even still at that point infertile. You have 2 cells that help during spermatogenesis, the sustentacular cells or the Sertoli cells. You need to know what that definition is. It provides a blood testes barrier around the sperm so that it isn't attacked by antigens in the immune system. And it also supplies nutrients and oxygen to the developing sperm and other cells. And then it also produces inhibin, which is a hormone that controls the rate of spermatogenesis, and we'll get more on that later. The second cell that helps during spermatogenesis is the interstitial cells or the Leydig cells. And this secretes testosterone, and we'll get more into that later. All right, hormonal control of the male reproductive system. Here you have the main male sex hormone is testosterone. We know that. It begins within 2 months of conception. So even while you're still in your mother's womb, testosterone is being made, and it controls the formation of the male reproductive organs and also the descent of the testes. If the XY 23rd chromosome is there, then that is what will happen. If there's no testosterone, then the testes do not drop and they appear female. Only one time in my years of working labor and delivery did we have a baby that something happened in the process, and either there was not enough testosterone to cause the testes to drop for it to appear to be male, and we could not tell. You could not tell by the exterior genitals if it was male or female. There was, we couldn't figure it out. So they'll have to do blood tests and sonograms and things like that to find that out. But lots of those things are involved even while you're still in your mother's womb for those sex characteristics to come out, and the hormones involved there help that. Okay, the after birth testosterone levels affect the male secondary sex characteristics. You need to know what that is. It appears at puberty, and it distinguishes men from women. So the male, you get a very distinct body shape, the pitch of your voice, and the distribution of body hair. Puberty, know what that is. The series of events that transform a child into a sexually mature adult is the definition of puberty. As a teen, testosterone also affects anabolism. You know what anabolism is? All the synthesis reactions that occur in the body. So anabolism is what helps you build muscles and bones, but it requires energy. And you've heard of anabolic steroids, you people that are into kind of working out. These are artificially enhanced anabolism. So they're taking this anabolic steroid to help build more muscle, but it also it's building bone and all these other negative effects with that. Anabolism is the opposite of catabolism. Know what that is as well. That is all the decompensation reactions that occur in the body. This is what produces energy. So testosterone also regulates the male sexual behavior and is necessary for spermatogenesis. You need that to be able to make the sperm. The levels of testosterone are controlled by the hypothalamus, and it releases gonadotropin releasing hormone, or GnRH. And this is what stimulates the release of luteinizing hormone, LH, and follicle stimulating hormone. The guys, they named these hormones after their function in the female, but even though they do a similar thing in the male, they just carried over the name. So they're named after the function of the female. So luteinizing hormone stimulates the interstitial cells in the testes to release testosterone, and the follicle stimulating hormone affects the sustentacular cells in the seminiferous tubules to increase spermatogenesis. Figure 16.7 shows you hormone regulation in males. And where is that? There. Okay, so you can kind of see how that works. All right. The anatomy of the female reproductive system. So male and female reproductive systems are complementary in function. Figure 16.8 shows you a picture of the female anatomy, and that will also be on your test. The ovaries produce the female gamete called the ovum, or the egg cell, and the female hormones estrogen and progesterone. The ovaries have tiny sacs of cells that surround and then release the developing ovum. You have a uterus. Another word for uterus is womb. Quite frequently you will hear that used. And the uterus is expandable to accommodate an unborn child if you're pregnant, or if you're non-pregnant, it's about the size and shape of an upside down pear. So quite small, but it can get rather large depending on how big the baby gets. The uterus has 3 layers: the endometrium, which is a thick vascular epithelium in which the zygote will implant. That zygote is what the term used for a newly conceived child if the ovum gets fertilized, then it will implant as a endometrium. You have the myometrium, which is a smooth muscle that expands and still stays thick. That's crazy. Smooth muscle all the way around the uterus that can stretch but still stay thick to protect the unborn baby. Then you have the perimetrium. This is the thin outer layer part of the visceral peritoneum. You have a thin serous membrane that covers the abdominal organs. Again, that membrane is there to help decrease friction so that it's not rubbing up against other things. You have the uterine tubes or the fallopian tubes, and these use peristalsis to move the ovum, the egg or the ovum to the uterus. So we've talked about that peristalsis action in your intestines and things like that. The fallopian tube does the same thing. It uses that same type of motion to get the ovum to the uterus. If fertilization occurs, it occurs here in the uterine tube. That is called the site of conception. So the ovum, once it is released from the ovary, it only lives a day or less, and it takes 3 days to travel to the uterus. So the sperm has to swim up into the fallopian tube to meet the ovum, to fertilize it there in the fallopian tube. Once it's fertilized, it's still going to continue moving down before it implants into the uterus, into the endometrium of the uterus. You have the vagina, which is a smooth muscular tube. Its function is for sex, and then as a birth canal, that's what the baby comes out of. And then also the cervix is an opening between the vagina and the uterus. It's a ring of smooth muscle. The urethra is not a part of reproductive anatomy like it is in males. In males, they only have the one hole, the one tube that is for urine and for the sperm to come out of. That's it. Females, you have 3. You have the urethra, you have the vagina, and then you have the anus. You have 3 separate holes in a female. The urethra is not a part of reproductive anatomy. It is only in the urinary system. My mother-in-law called me. This was, several years ago now, but she was helping take care of my husband's grandmother, and she went to the bathroom to help. She was old and could not, get around. So she'd have to lift her and get her onto the toilet. And so she went to help her, and she called me panicking because she had a hole and she didn't understand, what it was and what they needed to do about it. Well, come to find out, it was her urethra. And my mother-in-law, at I guess the age of probably around 50, had no idea that she had separate holes. So I want to make sure you guys are informed. You have a hole that you pass urine through, which is your urethra. You have a vagina, which is this smooth muscular tube that the baby will be delivered out of. And then you have a hole, which is your anus, that your feces will come out of. Okay, so now you're educated. You have 3 holes, girls. Okay. All right, moving on. This stuff gets a little bit boring. This is the oogenesis. The oogenesis on page 532, the development of the ovum. So we're just going to get through it just so you understand the process of how a baby is formed. The development of the ovum, the oogenesis, is the production of haploid germ cells by the ovary, which begins with the oogonia. These are diploid cells. Remember, 23 pairs of chromosomes. So figure 16.9 shows you a picture of this. By 4 months gestation, so while they're still in their mother's womb, 4 months gestation, the female fetus has about 5 million oogonia, and it begins meiosis then, but it stops in prophase 1, which is now called the primary oocytes. That's the beginning of the follicle, so-called primordial follicle. After puberty, only a few each month will continue to develop into an ovum. So a girl baby is born with all of the oocytes that she will ever have. So a man can always make more sperm, but a woman only has a certain number of oocytes and cannot make more. You cannot make more. So once those are gone and used up, you can't make any more. Anna, what's she have in her mouth?
Pancake.
Okay. Let me see. So at puberty, follicle stimulating hormone is released on a cycle from the anti-pituitary to stimulate about 20 primordial follicles to develop into the primary follicles and begin to secrete estrogen. So some follicles transform into the secondary follicles, which will increase the estrogen production. Here, the granulosa cells from a large fluid-filled space, which pushes the primary oocyte to one side, this forms a mature follicle. You can follow all of this in that figure 16.9. That mature follicle completes meiosis 1 to form 2 cells. You'll have 2 cells with 23 chromosomes. One is a polar body that's going to disintegrate. The other is the secondary oocyte that will continue ovum formation. That secondary oocyte, know this, secondary oocyte begins meiosis 2, but it stops at metaphase 2 and is called a germ cell. It's stuck here in this development at this point, so it's stuck there. It's called a germ cell. It's called a germ cell because it can develop into an ovum, but it probably won't. As the secondary oocyte matures, it continues to fill with fluid and then it bursts, and the secondary oocyte is released from the follicle called ovulation. So this is called ovulation. So once it's burst and then released, that ovum that gets released, that's ovulation. It's released to the secondary oocyte from the mature follicle. It goes down the uterine tubes toward the uterus. And it's just one ovum that will be released. After ovulation, the peristalsis is going to move it through the uterine tube. It moves that secondary oocyte. If it is fertilized, it finishes meiosis. Okay, so it's stuck in that phase, metaphase 2, that germ cell. Then it moves through goes through ovulation, moves through the fallopian tube. If it's fertilized, it will finish meiosis. The ovum gets most of the cytoplasm, and the tiny polar body is then going to die off. The leftover follicle becomes a corpus luteum, and you can see that also in 16.9, and that is going to secrete estrogen and large amounts of progesterone like it did as a follicle. All right, so the nice thing that you kind of learn here, I've seen people talk about this, that your grandmothers carried their grandchildren or even a part of their grandchildren in their womb as well. Because if a woman is carrying a female child, that female child has part, so the egg, the part that will then become a child in the future one day, it's even in the ovaries of that baby while it's being carried by its mom. So I think that's kind of neat. All right, the menstrual cycle. You might think, guys, that this is unimportant to learn about, but it's important that you understand this process for being married one day, but also having children and understanding what kind of goes on here. So the menstrual cycle is the development of the ovum. It's the release of hormones at various times and the growth and shedding of that endometrium lining inside the uterus. The cycle averages about 28 days, and it begins at puberty and is interrupted by a pregnancy and lactation. So lactation is the process by which a female mammal produces and secretes milk to feed her young. So those things pregnancy can cause you to not have a menstrual cycle, and also if you're lactating or breastfeeding a baby, it can keep the menstrual cycle from coming as well. So problems that can cause a temporary stop are excessive weight loss. Like we've talked about, so many different problems that can happen if you don't have enough fat in your body, right? You're not being able to produce the hormones like you need to. So if you're not being able to produce the hormones, then it can stop the menstrual cycle. You will permanently stop your menstrual cycle at menopause. This is the menopause. It stands for pausing your menstruation. So that's the last menstruation, the time of life after which a woman no longer ovulates. Usually around the late 40s to early 50s is when that will happen. Figure 16.10 shows you the menstrual cycle and the hormones that are involved in how that happens. You can see it's a 28-day cycle, and at around 14, all of the hormones, well, not all of the hormones, but the hormones are going to start to peak. The follicle stimulating hormone, luteinizing hormone, the estrogen has built, and then it drastically declines. That's what causes the egg to release from the ovary. And then progesterone is building. That's the thing that's going to help maintain a pregnancy, maintain the growth of the endometrium for the baby to implant and have a healthy pregnancy there. So you can see the growth of the endometrium gets bigger and bigger. And so does the growth of the progesterone, and the estrogen spikes as well. So all of these things are growing. As you can see, the bottom, the endometrium, that's the lining of the uterus, the inside of the uterus. It's growing with all of those hormones as well. Once you get to day 28, if that ovum or egg has not been fertilized, then you will have to shed that endometrium lining out so that there's not too much in there. So, all right, menses is the periodic shedding of the uterine endometrium, which results in blood loss from the vagina. So menses begins with what we call the period, the shedding of the endometrium that has gotten too thick to maintain. Some of the tissue is shed. So it's a sloughing off and bleeding. This is called menstruation. And it's that if you did not get pregnant, then you don't need your endometrium to be too thick. So once it's gotten so thick and you don't need it, it sloughs off some of that and bleeds out so that you're not building up too much. The first stage is called the follicular stage. The follicle stimulating hormone is increased here, causing about 20 of the primordial follicles to continue oogenesis. Follicles secrete estrogen, causing the endometrium to thicken. Luteinizing hormone, follicle stimulating hormone, cause the follicles to continue to mature. And about 5 are going to make it to the primary follicles. At the end of the stage, luteinizing hormone and follicle stimulating hormone reach their peak, right? And then they're going to decrease. So right at ovulation, luteinizing hormone, follicle stimulating hormone are going to spike, reach their peak, and then decrease. This is what causes the ovum to be released. So you need to know that for your test. Luteinizing hormone and follicle stimulating hormone, if they have decreased, then you know that you have ovulated, right? So what stage would that be in the process? Ovulation stage. So this is a positive feedback system. This is one of few in the body that we've talked about. Things that keep making each other increase until something gives, and it's the follicle that is going to give to end the system. So the increase until the follicle finally gives way. That's what stops the positive feedback system. So these the increase in hormones are what enables a woman to determine ovulation based on a urine test. So they used to not have that. And now you can test your urine to see if you are in that ovulation stage to help people who are wanting to get pregnant. At this point, the ovum travels to the fallopian tube. If it's not fertilized, it's going to die. It dies within 24 hours. Once it's released from the egg, only 24 hours does it remain living. But the sperm can live inside the fallopian tube for 3 days. So as long as it's in that range with the sperm and the egg being released, it can fertilize it inside the fallopian tube. So a narrow window. The egg's only 24 hours, but the sperm lived for 3 days. So you have quite a bit of area that you can work with. The second stage is the luteal phase. This is where ovulation begins, and the follicle quickly becomes the corpus luteum, which produces estrogen and progesterone. Progesterone is the dominant hormone of the luteal phase. Know that for your test. Progesterone is the dominant hormone of the luteal phase. So it builds the endometrium with oxygen and nutrients in case there is a pregnancy. So that thick lining, it's going to continue to build it. It wants it to be full of oxygen and nutrients, all that good stuff for the implantation of the baby. When you're not pregnant, the corpus luteum dies, and then the estrogen and progesterone decrease. This is what brings on the menses or the bleeding. If it is fertilized, the embryo secretes human chorionic gonadotropin, or HCG. So if you were to take a pregnancy test, a urine pregnancy test, that's the hormone it's checking for, or a blood pregnancy test. That's what they're checking for, because if it has implanted into the endometrium, it's going to start secreting that HCG, or human chorionic gonadotropin. So that's what they test for. It causes also, that HCG is going to cause an increase in estrogen and progesterone. That endometrium is going to grow thick as a result, because it's not going to get sloughed off, right? It formed an egg, the egg gets implanted, all of these hormones are being produced. There's no need for the endometrium to slough off. It's done its job. It's made a nice cushy bed for the baby to grow in. So a missed period is the first sign of pregnancy. So progesterone, that hormone, gets its name for progestation. This is what is it rises very high during pregnancy, and it builds up the endometrium. It relaxes the uterine muscles to allow it to stretch out. So it's a very good thing, helpful for pregnancy. Estrogen, it works outside of pregnancy as well as during. It's responsible for puberty in a female, and it maintains the female's reproductive systems. So that spike, going back to figure 16.10, that spike in follicle stimulating hormone and luteinizing hormone is what causes the ovum to be released, ovulation, into the fallopian tube. And then progesterone, as it increases, it's building the endometrium to prepare for pregnancy. If you are not pregnant, it has gotten too thick, you have to shed some of that tissue through menstruation or bleeding. All right, let's see. This is our last little bit, so we're almost done. I'm just going to continue and not make another video at this point. So just pause it and watch it when you have time. This starts fertilization, development, and parturition. Page 539. In figure 16.11, you can see that sperm uses the enzymes to break through the outer covering of the ovum. Once fertilized, it is called a zygote, which means paired. So zygote literally just means paired. The 23 chromosomes for the mom, the 23 chromosomes for the dad have paired. It gets equal amounts of nuclear, which is genetic material, DNA, from the parents, 23 and 23. But most of its cytoplasm comes from the mom. So you get all of the mitochondrial DNA from the mom. Any of the energy, all of that comes from the mom. The egg gives basically all of its cytoplasm. Remember, the sperm does not. It only gives that nucleus part, the DNA part. You need to list the stages of what happens here in order and what are completed before it enters the uterus. So once it's fertilized in the uterine tube, okay, the cilia and peristalsis are going to move it to the uterine endometrium, and it already has a has every genetic aspect here that it needs just from the fallopian tube. Everything that needs from forming, from them connecting, the egg and the sperm connecting, has every piece of genetic material that it needs forever. It's just going to develop. The father is what determines the sex of the baby, since his chromosome has an X and a Y. The female, a mom, can only give an X. Hers is X and X. So that's all a female only ever has X. The male, when his cells separate, it separates into an X and a Y. So it depends on which one the sperm is carrying, either an X or a Y is determined on what the sex of the baby will be. Because if it gives an X, the female is already an X. XX is going to be female. The sperm is carrying a Y. The female has an X. XY is going to be male. Okay, so dad is the one who determines the sex of the baby. At this stage, fraternal twins can be produced. Fraternal twins are when two ovums are fertilized and two genetically different babies are developed. So if you have twins that look nothing alike, this is how. It's because there are two eggs that were released from the ovary. Two eggs came out instead of just one, which is usual. Usually only one gets ovulated, but it can happen more. So that would be where fraternal twins, right? The man releases lots and lots and lots of sperm. It all determines how many eggs the female releases. So if the female releases more than one egg, you do have the possibility that both eggs get fertilized, and then you would have fraternal twins. Identical twins are one zygote during the cleavage phase and then many cells that develop under mitosis. If the cells separate or don't stay packed together really tightly, so you know when they're forming in that mitosis stage and they're pulling apart, they can accidentally get too far apart and pinch off and become two identical cells. They will form two separate but genetically identical individuals. Ella says hi. So they'll form two separate but genetically identical individuals. That's how you get fraternal twins, identical twins, the twins that look exactly alike, from the cell just pulling apart too much to form two identical cells. All right, stages of development. Ella, you want to say hi? Say hi. Hi. She's so sweet. Hi. Yeah, hi. Okay. Oh, y'all dropped a leaf. All right. So the stages of development. You need to know these in order. Remember, like I said, know these in order. I don't know why I said that earlier. List the stages in order and what are completed in the uterus. The zygote, first stage, just means paired, remember. So zygote, then cleavage. This undergoes mitosis, adding the cells. Then the third stage is the morula. You can see this in figure 16:12, zygote, cleavage, morula. This is around day 3 when it's still in the tube. Once it's produced enough cells, it forms a rough sphere shape that looks like a mulberry. All of these stages were still in the fallopian tube, okay? All of those zygote, cleavage, and morula, all in the fallopian tube. Know that. Now you're moving into the uterus. The fourth stage is called a blastula. You have about 4 to 7 days after fertilization where this takes place. The embryo begins to grow. Anna. The embryo begins to grow as cells continue dividing. So as cells press against each other, it forms a blastocell. This is a fluid-filled cavity that makes a hollow sphere called a blastocyte, which has a single layer of outer cells called a trophoblast. You need to know what a trophoblast is. This is the feeding layer. This will develop into the placenta, the umbilical cord, and the amniotic sac. The trophoblast does that. It develops into all of those things. That's what is going to provide the oxygen and the nutrients for the embryo until the placenta gets formed. So that's going to help give the nutrients and the oxygen and the blood and everything that the baby needs until the placenta is formed. In this stage is where the blastula is going to embed into the endometrium, got nice and thick and plumpy for it, and this is called implantation. So you answer the question, when did life begin? Fertilization in the tube or implantation, right? Some people like to say, oh, it's much later than that, and it's not really a baby because it can't take care of itself. Well, it had everything it needed genetically as soon as the sperm and the egg met. So in this stage is where the blastula embeds there for implantation. It's usually higher up in the uterus, away from the cervix, but it can form over the cervix. That can be a problem when the the woman starts to dilate to deliver. It can be bleeding if the placenta is if it forms over the cervix. Once the baby is implanted, the mom gives the nutrients and the oxygen through her blood, through the placenta, through the umbilical cord, and a new cavity forms from the trophoblast, and that is the amniotic sac. So the fifth stage here is the gastrula. The gastrula, the cells change shape and differentiate. They decide what they're going to do into 3 layers here. The ectoderm, endoderm, and mesoderm. The ectoderm is the skin, the nervous system, and the glands. The endoderm is the lining of the digestive tract and the respiratory system, most of the glands and the digestive accessory organs. The mesoderm, know what the mesoderm does. It secretes, it's for the circulatory system, your muscles, and your bones, but the mesoderm also secretes testosterone, so that's important. This is what will give rise to all of the parts of the body, like some of these. Then the 6th stage is the neurula. The neural tubes, neurula, you hear that, neural tubes, form about 3 to 6 weeks after fertilization. So once they fertilized in the tube, about 3 to 6 weeks later, the neural tubes are going to form. This is a flat 3-layer fold in a close like, a zipper to make the brain and the spinal cord all together. Their organogenesis happens here. That's the formation of organs and in a developing embryo. So this occurs anywhere from weeks 2 to 8 after fertilization. After about 8 weeks, you start calling it a fetus instead of an embryo. Some people don't like the name fetus. They want to call it a baby. Fetus is just another word for young one, right? So it's not a negative word. People just don't know the meaning of it. Fetus means young one. And they start calling it that. So it goes from a zygote, paired, where the mom and dad's chromosomes paired, to after about 8 weeks, they start calling it a young one because it starts looking a little bit more like a baby. So young one or fetus. Now figure 16.13, this is about 9 weeks gestation. You can see that the bones are forming. You can see that it looks like a baby here. The placenta is what allows the fetus to get the nutrients and the waste exchange between the mom and the child. So just like we bring oxygen nutrients and drop it off, we pick up the waste products and bring it back. And the same thing with the placenta. It brings in oxygen nutrients, takes away waste products. The capillaries between the two are close and allow for the gas exchange, for the exchange across the thin membrane without blood being exchanged. So it allows all of this to happen. Also takes over in producing hormones during pregnancy. So the placenta is what's going to be able to produce the hormones during pregnancy. The average human gestation is about 8 months and 3 weeks, or 266 days from conception to birth. So if you go by your last period, the first day of your last menstrual period, you add 7 days, subtract 3 months, you'll be able to get your estimated due date. Parturition. This is the process of childbirth. It begins with labor. The baby will signal that it's ready through the hormones, and the mom's estrogen and oxytocin will increase to cause contractions in the uterus. Again, a positive feedback system is what causes the contractions. More and more and more contractions. It's going to increase until something gives, right? Positive feedback system. So the fetus is pushed towards the cervix, causing it to stretch. If it's not opened, it's going to signal the brain for more and more to increase the consistency and also the intensity of the contractions to make the cervix open. So labor will last anywhere from 1 hour to 20 hours. It can last a really long time. So, all right, that is it for everything in this module. Let me go through and do a little test review for you. No figure 16.1, spermatogenesis, semen, spermatogonium, spermatids, sustentacular cells or the Sertoli cells. Study guide number 6 is helpful. Secondary sex characteristics, puberty, anabolism and catabolism. No, figure 16.8, that's the female reproductive system diagram. Study guide number 2 is helpful. Know that the secondary oocyte begins meiosis 2, but it stops at metaphase 2. It's going to be stuck in that phase. So secondary oocyte begins meiosis 2, but stops at metaphase 2. Now, if the egg or the ovum is fertilized, it finishes the meiosis. Know that luteinizing hormone and follicle stimulating hormone reach their peak and then decrease, and this is what causes the ovum to be released in the menstrual cycle. This is what ovulation is. On your own 16.8 and study guide number 10 are helpful. Listing the order of the fertilization of the, the development of the ovum. That was figure, I went the wrong way, 16.12, but it also continues after that. There were how many stages? 6 total stages. So list those stages in order and which ones are completed before they enter the uterus. That was stages 1 through 3 is still happening in the fallopian tube. Know that the trophoblast is the feeding layer that will develop into the placenta, umbilical cord, and amniotic sac. Know that the female, the egg gives basically all of the cytoplasm, and all of the mitochondrial DNA comes from the mom, not the dad. The mesoderm secretes testosterone. On your own 1610 is helpful, and study guide 17 is helpful. All right, that's it for lecture on this module. If you have questions, just send me a text or call or something. Continue reading, answering your questions, and you will take your test at the end of next week and then get everything sent to me so I can get you a final grade. Please, 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 please let me know about those other tests for you guys that have not gotten those in. All right, see ya.